As you know, I'm Kyneton the Genius, and today we are going to continue with data science and machine learning in Python and R. And today we are going to be going through a review of relevant math topics. One thing I want to assure you is that as a data scientist, you need to know some bits of mathematics. But will this math be very difficult? Will it be the advanced mathematics? No, it's something you can do, and that is what we are going to do in about 1 hour or thereabout. So just take your time to follow it. Don't skip any of it. If you don't have good background of mathematics, be sure that we are not going to be solving maths manually. We are going to be using Python to solve it. So feel free to follow along. If you have any challenges, you can let me know. So these are, again, I've also set up a Jupyter notebook, and we are going to start. And I've also have my notebook right here. I'm going to also be writing a few things using my tablet. All right, so let's get started. The first thing I want to present to you is the topics we are going to cover today. We have fundamental theories of machine learning that I'm going to skim through, which is probability theory, decision theory, and information theory. Applied probability theory, I'd like you to take some time to review it, where you have 3 balls, red and blue in a box. If you pick out one at random, what is the probability is going to be a red ball or a blue ball? So that's probability theory. I'm going to allow you to read up this in a textbook. Then we have also the set theory, a review of matrices, review of linear and nonlinear algebra, calculation and calculus 1 and 2, differentiation and integration, statistical theory, and number systems. Now the ones marked in black are the ones we are going to be doing right now using Python. Other ones marked in brown are theoretical, and while they are relevant, I would like you to take a textbook online and try to review it. It's really not going to be the difficult part of it. All right. So these are the 3 fundamental theories of machine learning, and all the mathematics we are going to be talking about, or we are going to be discussing, centers around all of this. So these probability theory, these are the topics I want you to go through: introduction to probability, probability measures, computational probabilities, counting methods. I think there is a textbook by R.J. Rice or something like that. Maybe I'll check this name of this textbook that explains it very clearly. You can use it to understand or get up to speed with probability. For set theory, try to review these topics. The sample space, what is it? The concept of universal sets, event, intersection and complement, empty set, the laws of set theory, and so on. So let's actually get started with our work for today. So I'm going to open Jupyter Notebook, and I'm going to start a new notebook by going to New and choosing Python 3. And this notebook, we are going to use it throughout the class today. Or maybe I can use one for matrices, one for calculus, and one for statistics. So I'm going to change the name to matrices in machine learning. All right. So this is matrices and machine learning, and now I'm going to actually speed through this. So we can do a number of things with matrices: add, subtract, divide, multiply, the dot product, the square root, sum, and transpose. So one thing I wanted to take note of is 2 ways to multiply 2 matrices. You can do the matrices multiply using the multiplication sign. You can also use the dot product. I'm going to explain the difference in a minute. So we are getting started right now. So how do you represent a matrix? A matrix is represented as an array or as a grid of numbers. For instance, I'm going to use the example in the example in the presentation. So we have a matrix. Let's say X is equal to 1, 2, 3, 4. So this is a matrix represented, and you also have Y is equal to 7, 8, 9, 10. So to represent these 2 matrices, you use the NumPy array to represent it. So let's just do it so that you see how it works. So I'm going to just put a comment that says review of matrices. So the first thing you want to do is import NumPy as np, and then I like putting the import statement in a different cell. So at this point, I'm going to create matrix X is equal to np.array. So NP data array, you open and close the brackets, then you specify the rows and the columns. Now the rows are put into different square brackets. So for instance, row 1 is going to be 1, 1, 2. So I specified row 1. What am I doing? So I specified row 1. So if I want to specify row 2, let me make it a bit clearer. So my insert is on. So if I want to specify row 2, I can just start another square bracket, and this is going to be row 2. All right. So at this point, if I just say print x, I'll have this matrix printed out. Okay, so I'll have np data array. So data type not understood. Okay, I'm simply going to just say np dot, let me just check, np dot array. Okay, everything should be fine. So I'm just going to say x instead of saying print x. I'm just going to say x. Okay, so np data array 1, okay, I think I made a little mistake. I'm just going to show you. Okay, so you're actually going to use a square bracket to enclose the whole of the matrix. So I'm going to just use the closing square bracket. So at this point, I'm just going to run it. And now we have the matrix created. So that's how to work with matrices. Now let's do some of the matrix operations at this point. So I'm going to add, multiply, divide, and do a whole lot of things at this point. So let's start with addition. So you can say x plus y, and you can see I'm printing it out. Okay, so matrix y has not been created, so I'm going to just create matrix y is equal to so have 5, 6, 7, 8, 5, 6, 7, 8. So this is matrix y. So at this point I can assign it, and if I say, I can easily say x plus y, and it gives me the result. So basically we are summing up different elements of the matrix to give us the correct answer. Now I'll allow you to play with the subtract, divide, but I'm going to now spend some time on multiply and dots. Now the multiply gives us element-wise multiplication of the matrix element. So for instance, I'm going to display my notebook. So let's talk about multiply of a matrix. So if you have something like x times y is going to give us 1 times 7. So you're going to give us 7, 2 times 8, 16. 3 times 9 should be 27, and 4 times 10 to be 40. So this is x times y, but this is not actually how we multiply matrices. How we multiply matrices in Python or in Jupyter Notebook, you have x dots y. So we call it the dot product. And what we are doing is we are multiplying, we are taking the rows of these elements and multiplying it by the columns of this element. So what we are going to be having is 1 times 7 plus 9 times 2. So this is going to give us the first element of the matrix, and the second element of the matrix is going to be so we'll take this multiply by this. So for this multiply by this, we are going to have 1 times 2, 1 times 8 plus we'll have 2 times 10. Okay, so this is the second element of the matrix, and the other element of the matrix is 3 times 7 plus 4 times plus 4 times 9. And the last element of the matrix is going to be 3 times 8 plus 4 times 10. So this is basically how to multiply a matrix. So in this case, this is the dot product of matrix multiplication, and that is what you're actually going to be using the element by element multiplication, which is this one, does not have any much significance in arithmetic. Alright, so I'll allow you to play around. So square roots, squares, take the square root of all the elements of this matrix, and so on and so forth. So I'm going to just move on to the next part, and that is linear algebra in Python. How do we solve system of linear equation? At this point, I'm going to start a new notebook. I'm going to just say this point, go to Python 3, and we are talking about linear algebra in Python. So let me give it a name, linear algebra. All right, so now linear algebra, I'm going to just give you a little background on how it works. At this point, I'm going to just clear bits of part of the screen or part of my board. So if you have something like, now I'm going to use the example in this place. So let's give a second. Okay, so let's say we have, I'm going to use x and y instead of a and b. So if we have x plus y is equal to 35, and we have 2x plus 4y is equal to 94. So this is a system of equation, and for sure you know it's linear algebra because there is no exponential, there is no x squared or y squared or cube or something like that. So how do we solve for x and y? Another name is simultaneous equation because we have two unknowns. For sure it could be 3, it could be 4 unknowns, but the way to solve it in Python is very simple. Now to represent this equation, to be able to solve it, you need to represent it in the matrix form. So how to do that? You simply say extract the coefficient of this equation. Here we have a coefficient of 1, we have a coefficient of 1, we have 1, 1, 2, 4. Okay, so this is how to represent it here. I'll have the unknowns to be x and y is equal to 35 and 94. Okay, right, so assuming we have this matrix to be A and this to be X unknown and this is B. All right, so what we have is AX is equal to B. So naturally X, which is your knowns, is equal to B over A, right? Or we can say B times A to the power of -1. So this is how to solve it. This is how Python solves this. The way it solves it in the system. This is the underlying method used by Python to solve linear equations. And now let's do it to see how it works. So the first thing I'm going to do, I'm going to say import numpy as np. Again, I'm going to put a little comment here that says working with linear equation, linear algebra, or linear algebra should be okay. All right, so I'm going to then go ahead to solve this equation. So the first thing we need to do is to represent this equation in a matrix form. So I'm going to say A is equal to np.array. Already you know how to do this. So have 1, 1, and the second column is going to be, the second row is going to be 2, 4, 2, 4, okay? And then we have B to be np.array. In this case, we have only two items, which is we call the result vector to be 35 and 94. So I'm going to run it as well, and I'm going to now solve it by using a method or a function called linealg. So I'm going to say x is equal to len np.linealg. Linealg takes np.linealg.solve np.linealg.solve, okay, and you specify matrix A and the result vector B, and that is going to give us x, okay. So I'm going to run it at this point, and let's look at the value of x and see. So it tells us x is equal to 23, x is equal to 23, and y is equal to 12. Let's check it. If we put in x3 plus y, that is, we have 23 plus 12 is going to give us 35. So this solution is correct. Again, if you have a larger number of variables of unknowns, then you can also use the same method. So basically, just convert the coefficients to a matrix form and then go ahead to solve it using linealg. So that is basically how to solve linear system of equations in Python. Let me see what I have next. So at this point, I'm going to move on to polynomials, because polynomials is actually where we have some work to do, as well as statistics. So let's move on to polynomials. Now I have the list of items we are going to be working with in the course of working with polynomials. We are going to be doing poly 1D, roots of a polynomial, poly. We are going to be doing polyfade, poly there, poly-int for integration, poly there for differentiation or for derivative, polysub, polymulti, polydiff, and polyval. Now let's go ahead to get started. Now again, take some time to use other sets of equations to try out what we are doing. So I'm going to be using only one example, but I want you to take a math textbook and try to solve the problems in there using different examples from a math textbook, okay? So let's start with the first one. Poly 1D is a function under NumPy, so you can always import NumPy. Poly 1D creates a polynomial. So at this point, I'm going to display my notes, and then I'm going to try to explain what we are talking about. Sorry, let me display my blackboard. I think this should be a blackboard, not a note. So the note is Jupyter Notebook, which is what we are working with on the web page. Now this is the blackboard. So I'm going to write on the blackboard at this point. So if we have, let's take for instance, let's take a polynomial to be x squared plus 2x plus 3. Okay, normally we can say equal to 0, but it doesn't matter. So this polynomial is represented in this way: 1, 2, 3. So if you give Python these coefficients, then Python is going to create the polynomial for you. The function that creates a polynomial by taking the coefficients of the polynomial is called poly1D. So let's go ahead to do it, and let's see how it works. So at this point, I'm going to shift this down a bit, and I'm going to again start a new notebook. So I'm going to go back home and just going to start a new Python 3 notebook, and I'm going to put a little comment there that says working with poly. Of course, polynomial is the key to nonlinear algebra. Okay, so and now we are talking about poly 1D. Poly 1D, okay. Of course, the first thing you want to do is to import NumPy. Okay, so let's create this polynomial called you having the coefficients of 1, 2, 3. So this polynomial, let's call it P, is equal to np dot poly 1D. So poly 1D is going to take the coefficients of the polynomial, or is going to take the array or the vector representing this coefficient. But I think the best thing to do is just to pass it the the sequence of numbers. So have 1, 2, and 3, and then I'm going to run it. Now if I see what P is, you can see it displays the poly 1D, 1, 2, 3. To print out this polynomial as the way we have it here, I'm going to just say print P, and it's going to print it out the way we have it. So we have 1x squared plus 2x plus 3. So poly 1D is something you need to know. Keep it in your mind, and the way to memorize it is by solving different problems or representing different problems using the poly 1D function. Now to evaluate this polynomial at a particular point, for instance, assume x is equal to 1. If x is 1, so we have 1 plus 2 plus 3, and that is going to give us 6. But let's evaluate this polynomial at let's say 1. So simply say P1 is going to give us 6. You can also evaluate this polynomial at another point, 0.5, and it's also going to give you 4.5. Now, to find the root of a polynomial, you simply say P dot R. The polynomial dot R is going to give us the roots of the polynomial. What is the root of a polynomial? The root of a polynomial is the solutions to the polynomial. So what are the value of x in this polynomial that is going to give this polynomial result in 0? So what values of x will make this polynomial 0? The roots of a polynomial are also called the zeros of a polynomial, the roots or the zeros. Okay, so keep that in mind. So to find the roots, just say P dot R. Let's move to the next one, the root of a polynomial. This is also very simple. So if we have a polynomial, I'm going to use exactly the same polynomial we are working with. For you, try to use the polynomial we have in the slide to work with. So to find the root of this polynomial, I'm going to just say roots is equal to np dot roots, and then specify the polynomial equation is going to be P. So if I run it, I'm just going to say roots. So let's see what roots we have. So it gives us -1, -1.4.14, and -1, and -1 dots, minus 4.14j. So it's actually having a complex root. Try to solve a polynomial that has a simple root and see how it works. I'm going to actually move on because we have a whole lot of things to cover. Now we have poly is another function. Now we've learned two. We've learned poly 1D, we've learned the roots. Poly is used to get the coefficient of a polynomial with a given sequence of roots. It returns the coefficient of a polynomial whose leading coefficient is 1 for the given sequence of zeros. So multiple roots must be included in the sequence as many times as possible as their multiplicity. So I'm going to write on the board to help you understand a bit clearer. So assuming we have a polynomial that we have roots -1 and -5. So this polynomial can be, this is the roots of this polynomial. So what polynomial gives us these roots? Maybe that is going to be x squared or minus 6x plus 5. Or maybe x squared plus 6x plus 5. Well, I don't know. So let's say we have sequence of roots, -1 and -5, and we want to find the polynomial that has these roots. So let's again go to our notebook at this point. I'm going to just shift it a little so that we can see both by blackboard. And so we are trying to have a polynomial that have a sequence of roots -1 and -5. So now I'm going to put a comment that says we are now working with poly. So the name of this function is poly. All right, so I'm going to say the polynomial p is equal to mp dot poly, and then we are going to provide a sequence of roots, and we want to see what polynomial have that sequence of roots. So I'm going to give my sequence of roots is -1 and -5. Okay, I'm going to run it. Okay, so what polynomial is that? Just check it. I'm going to see that we have 165, right? So 165, that is it. So it means that this polynomial is x squared plus 6x plus 5, right? So that is the sequence of coefficients for this very polynomial. So to see it as a poly 1D, you can say mp dot poly. Let me just say print mp dot poly 1D, and then let me just put the closing brackets and place p. So it can display it in a polynomial form, x squared plus 6x plus 5. Now, a recap of what we've learned poly 1D, we've learned about roots, and we learned about poly. Now we move on to polyfit. Polyfit is used to fit a least squared regression line, or it's used to create a least squares polynomial fit. So what are we talking about? If we have a sequence of values, then we want to fit or want to determine the function that relates this sequence of values, we can use polyfit. Now we are going to be talking heavily about this polyfit. We are going to be talking about regression, which is under supervised learning. For now, just know that if you have series of x values and y values, where x is an independent variable and y is a dependent variable, you can use polyfit to fit a linear regression line through this data set. What it simply means is just plot this data set on a scatter plot and then fit a regression line. Try to draw a line that passes through this curve through the data set. Let's now illustrate it. I'm going to make it quite clear at this time because this kind of relates to machine learning. So at this point, I'm going to just put a comment that says polyfit. All right, so we have a sequence of x is equal to dot array, and we have 0, 0, 1, 2, 3, 4, 5. Now I'm taking out the decimal point so that we don't waste so much time. I have y is equal to 0 np dot array. We also have this time 0, 0 0.8, 0 0.9, minus 0 0.8, and minus 1. Okay, so we have set of x and y values. Now, if we don't know the function relating these two values, that is for sure we don't know. So what we can do is to do a polyfit. Polyfit is going to give us the function that relates these two series of data sets. So I'm going to say z is equal to np dot polyfit. Okay, and we have x, y, and we're assuming d is going to be a degree 3 polynomial or a third order polynomial. That's just an assumption, and in machine learning later on in this course we are going to see that this means we are being biased. That is where the concept of bias variance trade-off comes out. So we are biased, we are just making assumptions that may not be true. All right, so np.polyfit z is equal to, so it says type error, x and y should have the same length, so I missed out something. I have 0.8, so we should have 1 at this point, 1 comma. Okay, so I'm going to run it again. All right, so what is z? Z now is the polynomial or the function that relates x and y. So f of x is equal to y. What is f of x? That is what we just got right now. So if I check what z is, it's going to give us this array, blah, 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 blah. So I can use z to now check what polynomial is that. I can say print. I can just say pz, the polynomial now is equal to np dot poly 1d and specify z. Okay, so and now let's check what pz is. I'm going to just print it out, pz, and now you can see that you have 0.537x cubed minus 0.62x squared plus 584x minus 0.68. So this is the polynomial or the function that relates these two variables. So given a new value of x, find y. You can predict the value of y given a new value of x. This is how to perform linear regression, and we are going to be talking more about this at a later time. So play around this using a different set of problems and try to make sure you understand exactly how it works. Now let's move on to another one, poly there. Now this is very interesting because this is used to find the derivative of a polynomial. So we are now kind of going into bits of calculus. Again, I'm going to display my blackboard and I'm going to kind of wipe away some part of the screen or some part of the board. Again, let me take a pen. So assuming we have a polynomial, we have xy is equal to x squared, x cubed plus x squared plus x plus 1. So the y, the x, by now I'm sure you have idea of how polynomials work, is equal to 3x squared plus 3x squared plus 2x plus 1, right? So this is going to be the derivative of y, right? So to find derivative in Python, I'm going to also just say let's first create the polynomial to be p2 is equal to mp dot okay, so mp dot, of course you already know about poly 1d, but let's just start by saying specifying the coefficients. The coefficient of this polynomial we want to find the derivative is equal to mp dot array. So it's going to be 1 1 1 1. So this is a polynomial you already know. Okay. Now we want to find the derivative of this polynomial. So we can just start by creating poly 1d. So mp dot poly. Of course, you may also not create poly 1d and just use the coefficients to find the derivative. So this polynomial is going to be coef. So print p2. So I've created a polynomial, as you can see right here, x cubed plus x squared plus x plus 1. So I'm going to just find the derivative. I'm going to call it der is equal to mp dot poly der, and I specify this polynomial p2, right? So if I run it, if I now check what der is going to give me this polynomial 3 to 1. So 3x squared plus 2x plus 1. So just to be sure, I'm going to just print it and print it out to the screen. You can say 3x squared plus 2x plus 1. And that is exactly what we have right here. That's about derivative poly there. Let's now go to polyint. So polyint is antiderivative of poly there. So let's also, I think I'll allow you to play around with this one and try to understand it because it's quite easy to understand. So at this point, I'm going to move on to the next slide. So polyadd is to add two polynomials. So in this case, you specify the two polynomials and then use polyadd to add it. So I'm going to just take one example and then I move on to something else. So assuming we have a polynomial, we have this polynomial here, and we have another polynomial z is equal to x squared plus 3x plus 2. I want to find y plus z is going to be x cubed, this is y, plus x squared plus x plus 1. And we are trying to add it with x squared. So you see where I'm writing, because I'm taking the degrees of this polynomial into consideration, plus 3x plus 2. And that is going to give us, so what we have here, x cubed plus 2x squared plus 4x plus 3, right? So this is what we have as the addition of these two. So let's solve this and then we move on to something else. So I'm going to go back to Jupyter Notebook and I'm going to so let's start by saying let's say x is equal to np dot poly 1d, and then we are going to specify the coefficient of this polynomial to be 1, 1, 1, 1. And the next polynomial we have y is equal to, the other polynomial is going to be 1, 3, 2, np dot poly 1d, and it's going to be 1, 3, 2. So if we now say x dot add y, so that is how to do it, x dot add y, and I'm going to just run it. X dot add y. So okay, so not add, it should be np dot poly add, np dot poly add. So we are going to okay, so some typo there. All right, so this is what we have, np dot poly add x and y. So all right, so this is how it goes. So I'm going to run it. So now if I check the value of z, print z, let's see. So we have z is equal to 1x cubed plus 2x squared plus 4x plus 3, and that is perfectly correct. So go ahead to take a look at polysub. It's just like polyadd, it subtracts two polynomials and it takes the same syntax. And we have polymul multiplies two polynomials, polydiv, the quotient of two polynomials, and polyval. Polyval actually evaluates a polynomial at a given point. So this I'm going to quickly illustrate it because we are kind of running out of time. So let me just display my note and let's illustrate this point. I'm going to clear my blackboard a bit. So let's say we have a polynomial that y is equal to 3x squared, 3x squared plus 1, okay? And we want to find the value of this polynomial at x is equal to 5. Of course, the value of this polynomial is going to be 3 times 5 squared plus 1. That is going to be giving us 75 plus 1, which is 76. Okay? So, in case of polyval, you are given a polynomial and you are given also a particular value so that we evaluate this polynomial at this particular point. So what we are going to do is to follow the same procedure. So I'm going to shift this so that we have some more room to work. So we have a polynomial, we have, call it y is equal to np dot, okay, so let's just say y is equal to 3, have 3, 0, 2. I'm sure you know why it is 3, 0, 2, because we have x in this polynomial is the same, this polynomial is the same as 3x squared plus 0x plus 1. So we have 3, 0, plus 2, I mean. We are working with plus 2 or plus 1. So we are working with 1. So I'm going to actually correct this. So that's how we have 301. Make no mistake about it. That is how the 301 came about. So now if we want to evaluate this polynomial at the value of x is equal to 5, so we are going to say np dot polyval and we are evaluating y at 5, right? So if I run this code, we have 76. The value of y is going to be 76, and that you can see, that is what we have here exactly. So this is how to work with polynomials in Python, and now we've completed working with polynomials. Now the next thing is about calculus, and after calculus we'll be moving into statistics. At this point I'm running out of time, so I'm going to end this particular part at this point, and we move to part 2, still review of relevant math topics, where we are going to be now reviewing statistics. Permit me to just go back to the table of contents so that Alright, so this is where we are. We've covered matrices, we've covered linear algebra, covered bits of calculus. In the next part of this module 2, we are now going to be looking at a bit of calculus, and we are going to now go into statistics, how to work with statistics, because in machine learning and data science, statistics is very important. It's a key thing you need to know, and that is what we are going to be doing in the next part. I also mentioned if you have challenges, let me know, and I'm going to give you the needed support. So I'm going to stop here, and I remain kind on the genius, and we meet in the next part.